Right now, millions of algorithms are silently fighting this high-speed bidding war on our highways.
Yeah, it's pretty wild.
It really is. I mean, they're deciding the price of freight and honestly, ultimately, the food in your fridge before a truck even arrives at the loading dock. So welcome to the deep dive.
Thanks for having me.
Today, we are totally tearing into the architecture of modern trucking.
Yeah.
Like, specifically, we're dissecting this massive leap that happened between 2025 and 2026.
Right, the turning point.
Exactly. When road freight basically stopped being this fiscal logistics puzzle and just became a pure, unadulterated data game. And for you listening, our mission today is to figure out how that happened. We're looking at a stack of industry research, primarily excerpts from a report called The Data-Driven Highway, Modern Trucking Analytics and Reporting Dashboards.
Which is a fascinating read, by the way.
Oh, totally. Because, I mean, think about the traditional trucking industry, right? It was like navigating a cross-country road trip using a 10-year-old paper map and, a leaky gas gauge.
That is actually a really good way to put it.
But today's reality is it's totally different. These fleets are essentially operating as rolling supercomputers.
Yeah, and if we connect this to the bigger picture, this shift was basically inevitable from 2025 onwards.
How so?
Well, we had this sustained, just explosive demand from e-commerce combined with wildly fluctuating fuel markets.
Right. Fuel prices were everywhere.
Exactly. And on top of that, you had tightening environmental regulations. So operating a fleet on just intuition or like retrospective reporting, it stopped being just a disadvantage. It became a literal mathematical impossibility.
Wow. So it went from a nice to have to a requirement.
100%.
Yeah.
Analytics transitioned from this luxury overlay to the core operating system of the entire supply chain.
Okay, let's unpack this mechanics-wise, because the central concept across all these sources is this shift to a single source of truth.
Yes, that's the holy grail of logistics.
Right, because for decades, a trucking operation was essentially just this messy collection of isolated data silos. I mean, maintenance had their diagnostic logs, dispatch had their routing software, finance was just, hoarding fuel receipts.
Everyone's speaking a totally different language.
Exactly. It's like different departments in the same building that just could not talk to each other.
Yeah.
And the modern dashboard acts as this universal translator. It forces all those disparate streams like telematics, ELDs, TMS data into one unified interface.
It does.
But I look at that and I have to push back a little. Aren't we just like consolidating the exact same historical spreadsheet data into a prettier digital screen? If the inputs haven't really changed, what makes the dashboard fundamentally transformative?
Well, it's really about the compression of time.
Okay, what do you mean by that?
Think about it. Consolidating historical data just gives you a faster postmortem on, why you lost money last month.
Right, which doesn't help you today.
Exactly. The real transformation is the shift to real-time operational visibility. We are talking about data streams with millisecond latency.
Ah, I see. So instead of a rear view mirror, it's more like a central nervous system.
That's a great analogy, actually.
Like if you touch a hot stove, your nervous system pulls your hand back before your brain even fully processes that you're burned.
Right. The dashboard is reacting to the operational friction before the financial loss is even realized.
That is crazy.
And that biological comparison works perfectly, particularly when you look at how the system monitors vital signs, the key performance indicators or KPIs.
Like what specifically?
Well, they've reached this level of required precision that leaves literally no room for manual calculation. Take fleet utilization, for example. The data shows that to maintain profitability in this current economic climate, fleet utilization rates have to hold above 75%.
Wait, why 75% exactly? What happens at like 74% that just breaks the business model?
It comes down to the ratio of fixed versus variable costs. I mean, a modern Class 8 truck is an incredibly expensive capital asset. We're talking often exceeding $200,000.
Jeez.
Yeah. And that's not even including the astronomical fixed costs of commercial insurance and financing. So when a truck is deadheading, driving empty or just sitting idle in a yard, those fixed costs are still burning cash.
The clock is always ticking.
Precisely. So at 74% utilization, the revenue generated by the active freight just no longer covers the amortization and insurance overhead of that idle time.
Wow.
Yeah, 75% is the mathematical tipping point where the fleet actually generates yield. And that margin is so unbelievably fragile that the system is tracking these tiny micro efficiencies like fuel consumption per mile and minute-by-minute idle time.
Idle time is a fascinating metric to me.
Yeah.
because it sounds so trivial until you scale it up.
Oh, absolutely.
Like a single truck sitting with the engine running at a loading dock doesn't really seem like a crisis. But when you aggregate that burned diesel across, say, a 500 truck fleet over a 300-day operational year.
You're looking at millions of dollars in just vaporized profit.
Millions. And the
Yeah.
dashboard changes how they respond to that, right?
Exactly. It doesn't just spit out a monthly report saying, hey, idle time is up 4%. It triggers an instant alert that truck 402 has been idling at a specific distribution center for exactly 22 minutes.
Which, I mean, immediately raises a structural question for me, and maybe for you listening too.
Okay, what's that?
Well, if the dashboard is pulling in this incredibly granular second-by-second data on idle time and speed and brake pressure, how does a human operator possibly process that volume of alerts without just turning into a total micromanager?
That's a very valid point.
Right. If I'm a driver, knowing that my dispatcher gets an alert literally every time I brake a little too heavily, that feels less like an operational upgrade and more like, I don't know, a surveillance state.
Yeah. And honestly, that tension between optimization and surveillance, that was the primary cultural hurdle of the 2025 rollout.
I bet.
But the breakthrough really happened when fleets stopped using the dashboard as a punitive tool, like punishing the drivers. And instead, they started using it for systemic safety analytics.
Okay, walk me through the mechanics of that.
Right.
'Cause how do systemic safety analytics actually function in practice as opposed to just, yelling at a driver for a hard stop?
Sure. Let's look at that harsh braking metric you mentioned.
Okay.
If a dispatcher calls a driver to reprimand them for one single harsh braking event, yeah, that is micromanagement.
And super annoying for the driver.
Right. But systemic safety analytics aggregates thousands of data points. So the dashboard takes that one harsh braking event and overlays it with telematics from 50 other trucks in the fleet.
Oh, interesting.
And suddenly it recognizes a pattern. It sees that every single driver is braking harshly at, say, exit 42 on Interstate 80.
So it isolates the variable. It's not a driver behavior issue at all.
Exactly.
It's an infrastructure issue, like a terribly designed off-ramp or something.
Precisely. And once a system identifies that environmental hazard, it feeds that data straight back into the routing algorithm.
No way.
Yes. From that point on, the system automatically routes fully loaded, heavy trailers to take exit 44 instead. It avoids the hazard entirely. It essentially removes the risk before the driver even encounters it.
That is incredibly smart.
It is. And when a carrier can take that empirical data to their commercial insurance provider and literally prove they are programmatically routing around high-risk infrastructure,
Their insurance premiums drop.
big time. And in an industry where insurance is this massive, dominant fixed cost, lowering it frees up capital that can then be redirected into higher driver compensation or newer equipment.
So the data protects the margins, which in turn actually protects the driver.
Exactly. It's a win-win.
And that pricing intelligence extends way beyond just the carrier, right? Because brokers and shippers are utilizing these same dashboard ecosystems too.
Oh, heavily. They're using them to optimize freight rates. They're constantly analyzing the spread between contract pricing and the spot market.
And they're doing it with unprecedented visibility now.
Yeah.
Like before, a shipper negotiating a contract was mostly just guessing based on historical averages and, market intuition.
Yeah, gut feeling.
Right. But now their dashboard is digesting real-time capacity data.
Exactly.
Right.
So if the dashboard shows that outbound truck availability in the Pacific Northwest is dropping by 15% because of an upcoming agricultural harvest.
The shipper knows spot market rates are about to spike.
Right. So they can lock in contract rates preemptively, securing their capacity before the market tightens up.
It effectively turns logistics data into a leading economic indicator.
It really does.
Like if researchers and journalists are looking at this aggregated dashboard data, they aren't just seeing truck movements anymore. They are seeing the actual velocity of global trade.
Yes, and that's huge.
I mean, a drop in shipping volume out of a major port registers on these dashboards weeks before it ever shows up in a quarterly GDP report.
It is arguably the rawest form of macroeconomic data available. But, and this is the key, if the data is coming in fast enough to act as an economic indicator, human reaction time is already the bottleneck.
Which brings us to the agentic shift.
Yes.
And here's where it gets really interesting, because this is the core of the 2026 transformation.
The big leap.
Right. The architecture moved from predictive dashboards, systems that analyze data to tell you what is likely to happen, to agentic dashboards. Systems that actually execute the decisions autonomously.
And that leap from predictive to agentic is just profound.
Give me an example of the difference.
Okay. A predictive system analyzes engine vibration, temperature, fluid viscosity, and flags that a water pump has an 80% chance of failing in the next 400 miles.
Which is valuable on its own.
Very valuable. But an agentic system, it takes that prediction, cross-references the truck's current GPS location with the inventory databases of maintenance facilities along the route.
Wow.
It books the service appointment at a facility 50 miles ahead, automatically reroutes the truck to that specific bay, and sends the end customer an email with a revised 45-minute delay on their delivery.
All without a human dispatcher ever lifting a finger.
Exactly.
Okay, let's break down the actual mechanism of a routing decision like that. Because applying that kind of autonomous brain to an entire corporate strategy requires a massive technological stack.
Oh, absolutely massive.
We are talking about the convergence of 5G networks, edge computing, API-driven ecosystems. How do those specific technologies actually facilitate an agentic decision in real time?
It's basically this incredibly fast, synchronized sequence of events.
Okay.
Let's say an agentic dashboard needs to reroute a truck due to a sudden weather event, right? First, you have the API, or application programming interface.
The digital bridges.
Right, the bridges that allow totally disparate systems to talk. So the National Weather Service API detects a flash freeze and sends a data packet to the fleet's cloud architecture.
And because of 5G, that transmission happens with near zero latency.
Correct, instantly. Then the cloud pings the edge computing node that is physically located on the truck itself.
Right, and edge computing is critical here.
It's
right?
vital. It means the processing power is right there inside the vehicle, rather than relying entirely on pinging a distant server back and forth.
Got it.
So that edge computer instantly calculates the current weight of the freight, analyzes the topography of an alternate route, and calculates the required fuel burn rate for the detour.
In real time.
In real time. Then it cross-references that extra cost against the spot market penalty for delivering the load late on the original route. It determines the most profitable path and updates the driver's navigation display. All of that computation happens in maybe 40 milliseconds.
That is just mind-blowing. But if the system is autonomously managing literally all those variables, fuel burn, topography, weather, market penalties, it really begs the question.
Are we phasing out dispatchers entirely?
Yes. Why do you still need a human dispatcher? It sounds like we are engineering a logistics network where humans are just biological bystanders, watching the algorithms run the supply chain.
It's a very common assumption, but the reality of implementation actually shows a very different dynamic.
How so?
Well, the agentic AI is taking over the micro decisions, the constant high-speed calculations that human brains are just fundamentally bad at processing at scale.
Sure, we can't do that math in 40 milliseconds.
Right. You cannot have a single human dispatcher simultaneously monitor the weather patterns, traffic congestion, and hours of service limits for a fleet of 3,000 trucks.
No, of course not.
So the AI handles that computational heavy lifting. And what that does is elevate the human dispatcher to focus purely on macro strategy and exception management.
Exception management, which is all the nuanced, totally unpredictable variables that an algorithm just can't resolve.
Exactly.
Like negotiating a complex delay with an irate warehouse manager or managing a driver's sudden personal emergency.
Precisely. Humans handle relationship management and strategic ambiguity. Algorithms handle computational optimization. And the fleets that recognized the symbiosis early on, they gained a massive competitive advantage.
Because their network was just constantly optimizing itself.
Exactly. Faster than humanly possible.
But mapping out this seamless API-driven utopia, it kind of assumes all these systems actually want to talk to each other.
Ah, yes.
And in practice, legacy architecture doesn't just vanish overnight. When we look at the real-world roadblocks to this whole transition, data fragmentation operates as this massive speed bump.
It's a huge speed bump.
Like, you can have all the APIs in the world, but if a carrier is running some proprietary 20-year-old dispatch software that absolutely refuses to integrate with a modern cloud architecture, the agentic AI is essentially flying blind.
Data fragmentation is a persistent issue, yeah. It's driven largely by proprietary data formats and legacy code bases that nobody wants to update.
Right.
And the scary part is, when fleets do finally manage to integrate everything into one unified cloud system, they expose themselves to a secondary, much more severe risk.
Cyber attacks.
Cyber attack.
Because you've centralized the vulnerability entirely.
Exactly.
I mean, if a bad actor gains access to a single agentic dashboard that controls the routing and fuel purchasing for 5,000 trucks, they aren't just stealing data anymore.
No, they're taking physical control of a massive logistics network.
That is terrifying.
It is.
Yeah.
The surface area for an attack expands exponentially when every single truck is its own edge computing node communicating via 5G. Cybersecurity and logistics has basically had to evolve from protecting databases to protecting moving, multi-ton physical assets.
Unbelievable. But even assuming a fleet somehow navigates the fragmentation and totally secures the network, they still run into what seems to be the most critical bottleneck of all: data literacy.
Yes, the human element.
This really stood out in the research for me. This idea that the technology can vastly outpace the human capability to actually interpret it.
It happens all the time.
Like if you hand a highly advanced predictive analytics dashboard to a fleet manager who fundamentally doesn't understand the underlying mathematics, the tool is useless.
Worse than useless, actually. It can be actively destructive.
Oh, really? Give me a scenario.
Okay, let's say a predictive model shows an anomaly, right? It flags that trucks are breaking down 15% more often on routes going through Denver.
Okay, Denver's high altitude.
Right. A fleet manager without data literacy might look at that, assume the high altitude is causing engine stress, and spend massive amounts of capital altering the maintenance schedules for every single truck heading west.
They see a correlation and immediately assume causation.
Precisely.
Hmm.
But a data literate manager, they look at that exact same dashboard, drill into the confidence intervals and the underlying variables, and they realize the altitude has absolutely nothing to do with it.
What is it then?
The system is actually flagging a correlation with a specific batch of OEM replacement parts that happen to be exclusively stocked at the Denver maintenance hub.
Oh, wow.
The parts are defective, not the route. So without data literacy, the AI's insight is completely misapplied, and it ends up costing the company money instead of saving it.
That is such a crucial distinction. But I guess the financial incentive to actually acquire that literacy is just overwhelming.
Oh, the payoff is staggering.
Because the data indicates that a fully integrated agentic dashboard ecosystem can drive operational costs down by as much as 30%.
30%?
Which is insane. In an industry built on razor-thin single-digit margins, a 30% cost reduction completely rewrites the unit economics of a fleet. It drops inventory costs, drastically boosts customer satisfaction with perfect delivery estimates.
It changes everything.
But I have to look at that 30% figure and consider the barrier to entry here, because achieving that requires 5G integration, massive cloud architecture, edge computing hardware, and a whole team of data-literate analysts.
Yes, it's not cheap.
So aren't we just building a digital divide that completely prices the smaller, independent mom-and-pop operators out of the market entirely?
Well, this raises an important question. It is arguably the most pressing structural issue in the industry today.
Because they just can't afford it.
Right. Historically, the barrier to entry in trucking was just the capital required to buy a physical truck and secure a commercial license.
Yeah, pretty straightforward.
Today, the barrier to entry is the capital required to build an enterprise-grade technology stack. There is a very real danger that massive enterprises implement these systems, hit that 30% cost reduction, and systematically underbid the smaller fleets on literally every major freight contract.
Because a mom-and-pop operation with like 5 trucks simply cannot afford the multi-million-dollar software required to compete on price.
They can't build it themselves, no. However, we are seeing a market response to this.
Oh, like what?
Software as a service or SaaS providers, they're emerging to democratize access to this exact technology.
Okay, making it cheaper.
Yeah, they are building cloud-based agentic dashboards that smaller operators can just access via a monthly subscription. It essentially allows a 5-truck fleet to rent the computational power of a 5,000-truck enterprise.
That's a lifeline.
It is. Whether that SaaS model is enough to prevent a total market consolidation, that remains to be seen. But it is the primary mechanism keeping independent operators in the game right now.
And the complexity curve is only going to steepen from here,
Yeah.
especially when you factor in the incoming wave of electric vehicles.
Oh, EVs change the entire equation.
Because the transition to EVs is going to require an entirely new taxonomy of analytics, right?
Absolutely. The operational logic of a diesel fleet just does not translate to an electric fleet.
Really? Why not?
Well, when you transition to EVs, you're no longer just tracking miles per gallon. The dashboard suddenly must monitor real-time battery degradation curves, the ambient temperature effects on cell efficiency, and crucially, local power grid rates.
Oh, right. Because the cost of electricity isn't static like a tank of diesel.
Not at all.
It fluctuates heavily based on grid demand.
Exactly. So if an agentic system routes a fleet of 50 electric trucks to charge at a depot during peak grid demand hours, the surge pricing alone could literally wipe out the profit margin for the entire week.
Wow.
So the AI has to calculate route efficiency, not just against time and distance, but against the highly variable cost of electrons at specific charging nodes along the entire route.
That is incredibly complex.
And furthermore, the dashboard is becoming a legal compliance tool.
I so.
As strict environmental regulations roll out, proving your carbon footprint down to the specific load is transitioning from just, corporate public relations to a rigid legal mandate. The dashboard will be the auditable ledger for sustainability.
Fascinating. So, synthesizing all of this for you listening,
Yeah.
what is the real core takeaway here?
It's a fundamental shift.
Yeah, the shift of 2025 and 2026 proved that trucking is no longer a transportation industry that utilizes data. It has become a data industry that utilizes trucks.
I couldn't have said it better.
The physical 18-wheeler is just the hardware, right? The dashboard is the operating system. So what does this all mean? It means that out on the highway right now, the most valuable asset isn't the cargo in the trailer. The most valuable asset is the data directing it.
That is the operational reality today. The entities that capture, process, and execute on that data with the lowest latency, they are the ones dictating the future of global logistics.
Which brings me to a final provocative thought I want to leave you with. Building on this whole concept of agentic autonomous systems,
Okay.
we established that an agentic dashboard on the shipper's side is constantly analyzing market data to automatically secure the lowest possible freight rate, right?
Correct.
And the carrier's agentic dashboard is simultaneously analyzing network capacity to secure the highest possible rate. So what happens when those two systems meet? When a shipper's AI and a carrier's AI start negotiating freight contracts against each other, countering and executing bids in milliseconds without any human oversight, who was actually driving the market then? We've traded the paper maths for edge computing algorithms, but we might just find that the algorithms are the ones deciding where the road goes next.